Have you ever wondered why cameras have motion blur? In real life, you can tell that it is rapidly turning, but a photo or the video captures it as if there are some parts lagging behind. Why is that? First, let's understand how light waves are received. Light waves can reflect from an object onto a sensor, like your eye, as long as there is a source of light. This is what we see in real life. A light source, such as a light bulb, emits light energy, which bounces off objects, and unabsorbed wavelengths are reflected back to the world. But if a sensor is closed off for a period of time, the photons cannot be absorbed by the sensor, and therefore don't get processed. Usually, this isn't much of a deal for slower moving objects, because the camera is able to capture enough frames of an object to make it appear to be moving smoothly. It is when things get really fast when things start to get wonky. Introducing the rolling shutter effect. The rolling shutter effect is caused by how cameras capture footage. While there are two main types of imaging sensors, the one causing the rolling shutter effect is known as the CMOS sensor. The CMOS sensor detects inputs through an array of pixels. The pixels are arranged in a grid so that the image can be orientated to how light waves are received. If these are out of place, you'll end up with a jumble of random pixels instead of a coherent image. When you click the shutter, the sensor records a frame by capturing the light waves from top to bottom. Once it has reached the bottom, the image needs to be processed and the shutter resets to the top, creating further delay. Now this creates an issue. You see, the sensor converts photons from light waves into electrons, which create an image. But not all of the photons are captured at the same time. Sometimes these can be a pain, especially when the image has text, which now has turned into a blurry alphabet soup. Several sites give tips on how to combat it. Long story short, you want the shutter speed to be faster than the rate at which frames are captured, so that the camera has enough time to reset before the next frame. Mind-blowing, I know. Keep in mind that the shutter speed differs between cameras. Nowadays, DSLR cameras can change the exposure time from every thousandth of a second to every half a second. Some photographers are masters at controlling the rolling shutter effect to create interesting images that would usually make absolutely no sense. Sometimes the rolling shutter effect is found by accident while attempting to capture a momentary memory. So, how exactly does it work? For example, here's a picture of a normal propeller. Everything is stuck together as we would expect it to. Now, here is a photo taken when the propeller was moving. That does not look like what we'd expect. Since the light waves are constantly traveling, some of the photons are blocked off during and after the click of a shutter. The propeller continues to rapidly turn, and the camera is only able to capture instances of their rotations. Thus, it cannot capture the whole image at once. This is what causes the end result to look like a fragmented object in a photo or a slow-moving object in a video. So the next time you see a really slow object in a video, take a second to think if it's actually moving faster than the camera can handle.